Now the last section today is organic chemistry. So some of you may have started, some of you may not have quite started organic yet. So I know we're all at different places with our teaching. So we're going to just start looking at a little bit of organic chemistry. And so next week we're going to be doing momentum and impulse. So please don't forget to send us some videos if you have got any questions on momentum. Right, so today's question came from the Mpumalanga's question, paper 2 on organic chemistry. And the question said, the structural formula of an unsaturated hydrocarbon is given below. And I just want to draw it for us quickly. So it had a carbon and another one with a double bond to a carbon and another carbon. So it had 5 carbons in the carbon chain. And on this carbon here, we had a branch. So I'm just going to put in all the hydrogens. So that is what the organic molecule looked like. All right, so just forgive me for just including all of them quickly. And remember, when you are drawing them out, remember this is a structural formula. So a structural formula is showing all the branches, all the bonds, and don't forget to count. So every carbon has to have 4 bonds, and then you attach a hydrogen or whatever to those 4 bonds. But always count and make sure you haven't got too many, especially when there's a double bond. So let us check that I haven't made a mistake. So there's the double bond, so you count 1, 2, 3, 4, 1, 2, 3, 4. So yes, so our structure is correct. So the first one said, define the term unsaturated hydrocarbon. Now, unsaturated just means there's a presence of a double or triple bond. So to define the term unsaturated, there are 1 or more multiple bonds. So multiple because it could be referring to a double bond or it could be referring to a triple bond in the carbon chain. So that would be our definition then for unsaturated hydrocarbon, would be an organic compound with multiple bonds, double or triple, within the hydrocarbon chain. Write down the Iupac name of the above compound. Okay, so ladies and gents, what we've got to do here is always to identify the longest chain. So that is critical. So the longest chain is what we refer to as the parent chain. So we need to go and have a look how many carbons are in the longest chain. Now don't forget the double and triple bond must be in the longest chain. So maybe it had a bit of a branch to it and the double bond was somewhere down below. It has to be in the longest chain. So always make sure of that. All right, so now we're going to have a look. So where is this double bond sitting? If I count from the left, it's going to be carbon 1, 2, 3. It's sitting on carbon 3. If I count from the right, that double bond is sitting on carbon 1, carbon 2. So you always number from the shortest distance to the double bond. So that is very important. So whether you're numbering it from the left, from the right, up, down, it makes no difference, but it must just be the shortest distance to the double bond. So we're going to number everything from the left-hand side, or from the right-hand side, apologies. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So now I see my longest chain is going to be a pent. So we're going to write it down here. So it's going to be a pent. Now what is special about this pent? Well, on carbon number 2, there's a double bond and there's the parent chain. So pent tells me 5 carbons. That 2 over there tells me on carbon number 2, ene tells me I have a double bond. So I've got a 5 carbon chain where on the second carbon there's a double bond. Great. So now we've identified the parent chain. Now we've got to identify this branch over here. Where is it sitting? It's sitting on carbon number 4. And what is that? That is a methyl group. So now in the front of this, we're going to write 4-methyl. Now it's got to be one word. All right, it must be one word with the pent-to-ene, so don't forget. So the name of that compound will be 4-methyl, one word, pent -2 -in. Unfortunately, the problem with the Iupac naming system is that if there's a hyphen missing, if there's a comma missing, you are going to lose marks. So we need to make sure our handwriting doesn't penalize us, and also that it's one word. So make sure of your handwriting. So let us rewrite that as you should be writing it. So it's going to be 4-methyl pent 2-ene. And there we go. So maybe practice writing the name on your question paper and then transfer it to your answer script so that you make sure that when you're writing it, you've included all the hyphens and that it's written as one word. All right, so great. So there's the name of it. Now they want us to write down the Iupac name of a isomer of the above compound. Well, this is an ene. So what we could do, we could just move the double bond across the chain. So instead of having it on position number 2, we could move the double bond to position number 3. So I'm going to draw it out again. So just to show you, so it's carbon 1, 2, 3, 4, 5. So instead of having it here, we're going to then draw it here. All right, so let's have a look now. Is that going to make any difference? That's what I want to show you. So if I put it on the original compound, so let me just go back to the original one. That is what the original one looked like. All right, so this is the original one that they gave us. Now, if I move the double bond from here to here is what I did. All right, is that actually a different compound? Let's have a look. Let us test. So we remember we got to take the shortest distance. Okay. So if I did that, this is carbon 1, carbon 2. So do you see by moving that double bond to that position, it's still on carbon number 2. So actually, it's not changing anything. All right, so we've got to test from left to right if it's actually changing positions, and it's not for the isomer. So we need to be very careful. All right, so possibly maybe not an option there. Maybe what we could do is to move the methyl group. So the methyl is sitting on carbon number 2. So keep the double bond constant, keep the double bond there, and move the methyl group. So this is what we had, and we had the methyl group over here. All right, so we're keeping that fixed. So now if we move that one to this position, I think that could work. All right, so that would be definitely a different position. So it's a positional isomer. We're changing the position of the methyl group. And how would we name that one? So we once again identify the longest chain. So it was pent. There was a double bond on the second carbon. And now we're going to have to look at the branch where it's sitting. So looking at this one, so it's carbon 1, 2, 3, 4, 5. So there we go. So this is still going to be pent 2-ene, so that is still going to be the same. So it's pent 2-ene, but we have changed the position of the methyl, and it's now sitting on number 3. Instead of the number 4 carbon, it's now sitting on the number 3 carbon. So now we can call it 3-methyl. 3-methyl pent 2-ene, and there we go. So that would be a positional isomer. We've changed the position of the methyl group from position 4 to position 3. Now keeping in mind the number of carbons, hydrogens, everything is the same. So the molecular formula is identical for both of these compounds. However, just by moving the position of that methyl group, we are changing all the physical properties of this compound. So it's a totally new, totally different compound with a totally different boiling point, etc. So isomers, remember, they will have the same molecular formula but different structural formulae. All right, so looking at the next question, I see here they were a bit sneaky. They introduced a reaction, so organic reaction, into the fundamentals on organic chemistry. And now they say this hydrocarbon reacts with bromine water. Use structural formulae and write down a balanced equation for the reaction. Okay, so now I need to go find a little bit more space, or maybe I can squeeze it in here. So let us have a look how I can do this. So we've got 5 carbons with the methyl, and they want structural formula. So remember, we have to draw them all out, so it's going to get a little bit crunched and a little bit messy. And remember to count 1, 2, 3, 4, 1, 2, 3, 4. So be careful you don't put too many or too few bonds and hydrogens. And there we go. So we've got our organic compound, and now we are adding bromine water. So bromine water is just Br2. So we will then write it out, because they're wanting structural formula, you just write bromine and then obviously draw the Cooper notation that there's a sharing of a bonding pair of electrons with another bromine. So it's just a standard way of doing it, because they ask for structural formula. And structural formula actually only refers to organic molecules, but generally we tend to also write the inorganic molecules like bromine and show the bonds between the bromine atoms. So there we go. Now this kind of reaction, I see I've got a double bond. So what kind of reaction is going to happen here is actually going to be an addition reaction. So what's going to happen, the double bond is going to break, and the bromine atoms are going to sit on each carbon atom of where that double bond broke. So we need to make sure that the bromine atoms are sitting on either side of where that double bond was sitting. So we're going to add it. So once again, we need to draw our 5 carbons. So 1, 2, 3, 4, 5. And where the double bond was, we're going to go add on the second carbon. We're going to go add a bromine, and onto the third carbon, we're going to add a bromine. And now we can just add the hydrogens. And there we go. So remember, with this reaction, we are breaking the double bond, and we are adding bromine to it. And there we go. All right, so it's a little bit on the messy side, and I do apologize for that. All right, but what is important, so here's the double bond, and I'm going to break the double bond here, and at that point, I add a bromine, so I've got a single bond now. Instead of a double bond, I have a single bond between the 2 carbons, and now I'm forming a bromine, a dibromo alkane. So we're going from an unsaturated to a saturated. So remember, this was an unsaturated compound. With an addition reaction, we then go to a saturated compound. Write down the name of the type of reaction that occurred. This is a addition reaction. All right,